Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about drive-by-wire cars. So let's dive deep into it. So what the heck is the idea? The idea is no more mechanical linkage for control. Meaning if you saw any old warplanes of World War II, you must have seen there was joystick. There was freaking wire at the base of it that you were pulling. It was going through pulleys and then it was controlling the ailerons and all that jazz. And that's a very common system. You look at the old cars, very old cars, you can physically see the gear train where it's like, oh, you are rotating it, that's rotating this, that's how the gear rack is moving. And these are what we call mechanical linkages. So idea is we gonna do the same thing, basically have user input reacting to the basically causing an action out of vehicle, but instead of a mechanical hard link, we're gonna replace these things with electronics or wire. That's why drive-by-wire. You are doing the same thing, only the linkages have been replaced by physical hard links, either hydraulic links or cable links to drive-by-wire system. And here's the deal, we have been slowly doing this with everything. Like, to give you a context, how early the system started was Concorde. Now you have to understand, Concorde was way too ancient plane. Meaning, how ancient? There was no such thing as digital computer then. Like, digital computers had not came into prominence as a full-fledged system. So they had analog computer on board, and that used to filter out all the pilot's input, then apply it to the surfaces, ailerons and all that jazz. So now you're like, why? Well, here's the deal. This plane had to operate in much wider ranges, as in regimes, as they call it. So subsonic when it's landing, sonic when it's trying to transition, and supersonic when it's doing the cruise system. So the inputs had to kind of change. Basically, if the same type of input is giving in one, it will not work with the other. For example, the inputs that are working at supersonic will not work at subsonic. So you needed a way to filter those things. Now, can a pilot do it on their own? Yes, but when you have people on board, you do not want oops to lead to crash. So for that reason, drive-by-wire. And in case of fighter jet, because of the cost and complexity and the boom potential, even these things started to go drive-by-wire. And even giant puppies like Globemaster, it was drive-by-wire. Space shuttle, drive-by-wire. Meaning, if you look at old passenger aircraft, the yoke, the passenger, basically the pilot yoke, was literally controlling valves in the valve train that was affecting the hydraulic pressure in the control surfaces. However, in modern system, there is no control. Like, the valve train is still there, is just getting controlled by electronic system. So the pilot input is getting filtered exactly how it was getting filtered in Concorde. Every major airlines right now, modern planes, do the same thing. Basically, you have control input, it goes through a filter, a checklist, quote unquote, and then it goes to the main valve train, then it does. Now, if the software is wrong, yeah, it will cause accident. And yes, it has happened. You know the name of that, Boeing. So it's a thing that we have been doing with aircraft, trains, boats, everything in between. Heck, even your hard drive went from mechanical things that are moving to just SSD. So we have been doing. Now, question becomes, why? Why go through so much hassle? Well, the reality is electronics have become far more powerful, not only in terms of semiconductor processing ability, but also in terms of oomph. Meaning, back in the 1950s, or even before that, if you went to anyone and is like, hey, I want a motor that is this size and it should have 1 horsepower, they're like, bro, what are you smoking? That's not possible. We buy it and throw it in normal, drone motors are more powerful than that. Literally. Drone motors are this small now. So you get the point. We have reached a point, the oomph of electronics is genuinely powerful. Heck, many modern aircrafts, they are trying to, F-35 fighter jet already has this, but many future ones are already planning to ditch the hydraulic system, have electrical system right on the control surface. So motors will drive everything, and then you're gonna have control wire. In some passenger aircraft, they're like, hey, we have so much control wire now, it's hassle. What if we yeet all the control wire and put fiber optic there, so drive by light? So the idea is you can have power wire, and you just remove the signal wire. Now, like, if you already have power wire, why you want to remove the signal wire? Power wires do not care about interference, signal wire do. And not to mention, you have multiple signal wires. Like, the wire harness becomes majority of signal wires. Like, so much signal wire is there. Fiber, to fiber, done, go home. You can have terabytes of data transition in from A to B without any issue. So that's the whole idea. The electronics became more powerful. It also became cheap because of the mass adoption of electronics. The cost started to come down. So you can do a lot more without actually spending a lot more. And then we come to the critical aspect. It's adaptive, meaning not only it can take your input and pass it on, it can filter it out, it can adapt to it. Meaning if you have an input, let's say how much control authority you have, and computer can literally react to it. It's like, hey, the aircraft speed sensor is telling me that I'm in this regime, as in like now the control authority should be dampened so it does not cause any hassle. So then like, okay, it's gonna adapt to it. And then it's like trying to land and it's crosswind and all that. It knows that, hey, you are at slow speed, you need as much authority as possible. It's gonna adapt to it. That's why all the planes are actually going in. If you remember Top Gun movie, there was a lever in the handle. The moment they press it, it overrides the computer. What does that mean? That simply is the moment you press that lever, computer goes, okay, go YOLO. Basically push the vehicle to upper limit. If you do not press it, like most normal operation, it will not allow you to. So you will not do a action which will cause a bending of airframe. But if you are in a combat mission, somebody is actually booming you, at that point in time, it's like, yeah, if I'm boomed, the plane is boomed. So plane is like, okay, here's a button, press it in case of emergency. And be mindful, this was there in very early days also. And there were mechanical computers like governators or jet engines. They were like, jet engines will not rev up beyond this point. But if you are in a combat operation where it's like, I need that extra oomph, they will unlock it. And yeah, it will damage the engine. But it's like, if you do not, you will be poofed. They're like, okay. So adaptability is the critical aspect. And now it's economical too. Meaning if you want to design a passenger airlines, let's say Airbus A380, you want to design something big daddy like that, doing it with electronics and fiber optics and all that would be cheaper than actually having physical hydraulic lines. So that's the idea of it. So we are taking all this development of last 50 years and cramming this puppy into vehicles, so to say. Now, the first thing that should come to your mind when you are talking about electronics is that you need electricity, you need power. So where the heck you're going to get power? And be mindful, modern cars already have a lot of high auxiliary draw, from your headlamps to your fog lights to your electric wipers to your electric windshields to basically electric rear heaters, seat heaters, and air conditioner and dashboard, sound system, all that jazz. So you have, and let's not even talk about steering motors, power steering and all that jazz. You have way too much electrical load that are not driving load. So your engine not only has to drive the car, it also produce enough electrical power to drive all those things. So we need to create a point where we are understanding that our load has increased. So we used to have 6 volt back in the ancient time of Henry Ford. Then we upgraded 12 volt. Then we kind of got stuck there for way too long. Way too long we got kind of stuck there. So 12 volt as of now is not enough for modern cars. Basically, we are reaching a point where brute forcing 12 volt to work, it is unhealthy. So amp draw becomes too high. So the wire harness in modern car is huge, as in multiple kilograms of copper have to be used just for wire harnessing, because the voltage is so low and we have to send so much amps through it. So slowly all cars as of now are moving to 48 volt system. Now, if you are an Elon Musk fan, you will think Elon Musk is the one who is doing this. But if you are anyone with a brain cell, you would know that this system has been tried in 90s. And back in that day, it was called 42 volt electrical system. Like, wait a minute. These numbers sounds very odd. Why exactly 48 volt? But here's the electrically, it's kind of agreed upon that as long as you are below 50 volt, you should not have a scenario where if you touch the live and neutral, you should go poof. Basically, electricity should not penetrate you unless you have an injury or wound or wet hands or something like that. 48 volt should be the upper limit where people are like still safe to call it non-live voltage. But what happens if you go higher voltage, like in case of EV where you have 400 volts, at that point is classified as high voltage, as in danger to you, meaning the insulation, the safety rating, all that just goes exponentially expensive. So even with USB-C power delivery, when they wanted to send more power to it, they just did not increase the voltage. That was the primary reason for that. As long as they were keeping it to 48 volt, they did not need to basically safety rate the electronic system. So 48 volt is the kind of upper limit. That means you have to have 4 12 volt batteries. Now, back in those days, 90s, when they were trying to lead acid, people knew that it's not going to go further. So people were moving into nickel cadmium systems. Now, that system has a different cell voltage compared to lead acid. That's why the 42 volt system. So that was in 90s. People did try that, but it was kind of teetered out simply because the biggest invention at that time was electrical steering power, basically. Powered steering using electrical. Before that, we used to rely on hydraulic. So that change was like kind of dampened it. It was like, dude, we can develop a 12 volt system that can work on it. But now it's reaching a point where it's like, dude, we are just forcing it. And here's the deal. If you want to buy basically 48 volt subsystem in an electric car or in an internal combustion engine, buy cars. They already exist. Audi has it, Porsche has it. There are many companies that have it. That's why I'm so shocked. People are like, Tesla is changing the industry. 48 volt system is the biggest thing. I'm like, you can buy it. Buy it as in like money, car, now, go home from 2017. And even older than that. Let that be vague. 90s, we were trying that. And many cars were actually made and sold. So it's an old system. So, okay. So we have to increase the voltage from 12 volt to 48 volt. Okay, got it. How the heck you get the power? Well, you take BLDC, you go into your car engine and you yeet the starter motor and you yeet the alternator. You take those things and you destroy them and you replace them with one BLDC. Like, wait a minute, how? Well, here's the deal. You have a shaft, just plonk it there. Why? Well, here's the deal. When you're talking about parasitic load, alternator is a parasitic load. It's always there. And not to mention, not only it has a pulley load, basically you have extra bearings and pulleys and belt. You also have electrical contacts that are slip ring. So that's also putting a lot of parasitic loads. Not electrical load, parasitic load. So you have something that is always spinning, whether you are consuming the electricity or not consuming the electricity, meaning you can't control it too much. Somewhat control you can do, but there is too much physical electrical stuff. And then you come to starter motor, which is the worst sort of system engineering wise. It literally has an electromechanical system that goes fudging. Now here's the deal. Doing this sounds very good, but here's the deal. It fundamentally means you have a wearing component, a component that's going to wear down, meaning it's not going to run for very long. You have a component, and that's why in like truck motors, that system, the gear tip, that smaller one, is designed in such a way that it wears before it wears down the flywheel. The reason for that is that smaller one is easier to replace. We had to design it that way, like it will wear down. If you use your car long enough, it will wear down. So we have a clunking, ka-ching, brrr. All that is too much hassle. It has too much physical parts, too much, it's just wasteful. So you throw away the alternator, you throw away the starter motor, and you replace it with this puppy. Now this puppy is a BLDC motor, which if you know anything about science, you know the fact that motor and generator are the same thing. So somebody figured it out. Thankfully, you can buy this in, well, two-wheelers. If in India you have bought any scooty recent times, most of the scooties already have this. Even some bikes have this. So the benefit of that is there is no physical friction of like, electrical brush or that mechanical khatang. So it's far more efficient. It gives you far more power. The same thing allows you to actually spin it up. So starter motor is not a thing that you have to connect and disconnect. Efficient. Same thing. Now again, in India it's already available for two-wheelers. Four-wheelers, if you had BMW and Rolls-Royce, they already had this system. I do not know other brands also, but I'm pretty sure most of them have this sort of system in their luxury lineup. It allows you to get more power, less parasitic loss without having less components. Basically, it's win-win-win-win in all scenario. And to help the matter, some development that have happened, that is this puppy, that is 48 volt AC compressor. Now why that is a good deal? Well, if you know your AC compressor in your car, you know for a fact that it leaks coolant. The basically refrigerant, it always looks. Why? Because it has a gland that goes through a shaft that is spinning. That is fundamentally a leaky design, and it has to be. They cannot tighten the gland too much. If they do, it will burn out. From the friction. So that's a, like, they make sure the leak is low enough, but you always have to replenish your air conditioning regularly, so to say. Now compare that to your refrigerator. You do not even have to worry about it. You most likely throw away the refrigerator unless it has some damage. Most likely it never leaks. Why? It's encased electrical system. Encased electrical system. You no longer need a belt to send the power there. So you no longer have contact. You have electrical contact, which is much easier to seal. It's a static contact. So that allows AC to become non-parasitic, meaning it will only drain power from the electrical system if it needs to. If it's on, it will drain power. If it's not on, it won't be a parasitic load that your car engine always have to waste around 2 to 4 horsepower on it constantly. So every car company that is making like a sedan, a basic sedan, and they're like, okay, let's be efficient, they can get a lot of efficiency, almost 3% to 10% mileage efficiency just by switching the system, throwing away the alternator, throwing away the starter, putting one BLDC, having 48 volt AC system rather than belt driven system. And what if you are rich puppy and you want some oomph? So most likely you're gonna go with diesel. In diesel, there is a problem known as turbo lag, meaning you press the accelerator, car does not fly. Because what will happen, you press the pedal, ECU will like, I got you fam, it's gonna squirt fuel into the cylinder head, it's gonna go exhaust pressure will build up, it will slowly spin up the turbine will slowly spin up the compressor. It will take like almost a full second, or maybe sometimes 2 seconds, to actually reach a RPM where it gives you the boost. So you like, you press it, it's like oh, now it's giving the power. So there is a lag. So in F1, somebody came up with the idea, it's like, what if we put a motor generator unit right there? So when the accelerator is pressed, ECU is like, I got you, fam. It knows for a fact that it will take time to spool up to that level, so it will send power to the motor generator unit. Motor is gonna go wabam. In case of Audi designs, it can go wabam in quarter of a second and goes full RPM. So you get full boost instantaneously. You press the accelerator, car goes. Now here's the what happens in normal design. The moment you reach that peak load, your turbo starts to reach into what we call a runaway. It starts to go more and more and more. But here's the deal. Then you open a valve, drop the pressure. Here's the deal. Nowadays, you don't do that. You just say, oh, you are getting more power? No problem, sir. That motor is now acting as a generator. So now it's putting load. So you are getting excess energy from exhaust. So exhaust pressure is being converted into electrical energy. This is what we call in F1 thermal energy recovery system. Basically, you are also dropping the temperature, you're also dropping the pressure, and you're getting energy out of it. It will not affect your main engine. So it's efficient. Marine industry, they are relying on this to get auxiliary generator. They have the main engine, auxiliary is just turbo. So this is available. So that's why you solve that's how you solve the power part. You have a BLDC, increase the voltage, and have this sort of system. Now you have enough oomph to do more things while reducing your carbon footprint. Then we come to the two major input, brake and accelerator. Now you have to understand, accelerator was let go long ago. We let go of accelerator before we even knew it. So because modern ICE engines, internal combustion engines, does not have petrol, diesel, CNG, whatever have you, they are controlled by ECU, engine control unit. So how do you control the engine control unit? You don't. You just send it a signal. So back in the ancient time of carburetors, we used to have this puppy, which you see in Fast and Furious. So this was a control mechanism where you are controlling physically. Your leg was directly controlling this valve position. So what do we have now? Well, if you ever paid attention that modern cars have plastic systems, the reason for that is all it is an encoder. Encoder just tells the ECU, it's like where the driver has pressed the pedal. Based on engine mapping, engine running condition and all that, then ECU makes the decision, and then it's like, okay, I'm going to give this much fuel. That's the whole point. That's why I said like the adaptability part. So if engine is already running at kind of hot RPM, it will not directly go boo. If it is very low RPM, then it will understand it's like, okay, the maybe guy is trying to do a takeover maneuver. It will like, okay, go bye-bye on it. So that's the whole point, adaptability. So ECU has a lookup table based on the position based of all the other vectors, it analyzes it. So if you ever noticed a plastic accelerator, it's just an encoder. And be mindful, older ones had a metal one, but they were still encoder only. There was no physical connection. We let this puppy go long ago, as in like 1980s. We let it go. Brakes. Now brakes are already electronic, meaning if somebody can mess up your electrical system, your car can stop without you touching the brake. It has enough electrical oomph to actually do it. So we have anti-lock braking system, which again utilizes hydraulic pump to create the pressure, and hydraulic valve actuators where it's going to balance out the power in all four systems. So you get the point. Like we have reached a point where car is same way steering is electrically assisted, your braking is already assisted. On top of that, we have electronic brake force distribution, emergency braking system, all those things. There is more than enough oomph in your car to just stop the car on its own. However, as of now, there's still a physical link, meaning in case of electrical failure, if you press the back pedal, it will mechanically cripple it. It may not be safe because ABS allows your vehicle to be far more safer, but there should be a failover, meaning if you press the back pedal, you can stop the car without too much hassle. Meaning if 100% electrical failure happens, you still should be able to stop your car without any issue in case of EMP boom. Now we come to the most naughty part recently, steer by wire. Now steering by wire is very difficult simply because, not like mechanical steering is hard to do, simply because at slow speed it's difficult. Meaning if you had Henry Ford vehicle long ago and you were driving it at any speed, let's say 30 km/h, it's butter. You're like, I got this. Now, problem is the moment you slow down in stop and go traffic, that's why you needed the oomph, the man. That's the problem. Slow speed, it's counterintuitive, is that the slower the speed, the worse it becomes, because almost you are trying to move a dead load. So we needed power steering. So, and this is another reason why you have such a much steering, physical amplification. So even in case of a steering motor failure, if you rotate your steering wheel, because you are amplifying the rotation, it will be like you have to rotate it 4 times almost to move the wheel. So you can physically do it. It's uncomfortable, but you can do it. Steering motor just makes it super easy. Power steering motor, so to say. Now, there is always a physical link. There is a physical connection, always, all the time, physical connection. But physical connection comes with a issue of steering ratio. Now, steering ratio is that if you have too little steering ratio, meaning 1-to-1 mapping, you're going to crash at high speed, meaning even a little nudging will be like, bye. So that was another benefit of having that high ratio. Now, high ratio becomes a hassle when you have to do full turns at slow speed. And why do you think we have steering wheels? Because why do we need to do this? Well, at parking, we do not need at high speed. Remember, like whenever you are driving at high speed, you're just like chilling. But when you are at like parking, so that's the steering ratio. Now, when you have a mechanical connection, you can't do anything about it. But when you have electrical, adaptability comes in, meaning now you can map it, meaning it can look into the ECU, it can study all the car sensor data, and it's like, hey, the car is at this speed, how about we change the ratio? Car is at really high speed, how about we dampen the steering? How about car is super duper high speed, how about we dampen it more? How about the car is stop, how about we amplify it? So that you can do. Now, there have been attempts about this. This Lexus is the newest high priority attempt. Now, will it be successful? Most likely it will be, because once people realize how comfortable it makes in city traffic, when it's like, oh, you do not have to go dink chika, you don't have to do that. People like, shut up, take money. So many OEMs also manufacture part for it. If you want to buy it, you can just buy it. So steering by wire is doable, but as of now, there is nothing major about it, whereas like every car company is doing it. But it will happen. I can easily see this puppy happening in, let's say, the next 40 years. It will happen. 40 is being too optimistic. As in like, I'm too conservative. Future. So here's the deal. There are two types of people. You must understand this part before you dive deep into it. Is that there are enthusiasts and there are simple people. So enthusiast people care about driving. It's like, it's not safe, or it's not this, or I will never trust this, or that's like, dude, have you ever flown a plane? It's like those people who care about, like those people are like, we want manual. I'm like, I get it that you want to waste your life pressing clutch pedals, but yeah, most people are not getting paid to do it. Again, if you are a F1 driver, and be mindful, F1 does not have clutch. So if you are getting paid for it, go you learn it. Most people are not getting paid for it. Most people do not like to drive. Heck, I have a car. I thought, like, when I was like, yeah, I got the car, and I was like, yeah, I'm gonna drive. It's like 5 minutes later, it's like, yep, and mine is automatic. Nobody likes driving. It's like, it's one of those things that you think it would be fun, but it's like, once you actually do it, it's like not that fun for most people. But for the loud minority, very loud minority, they make out so much about it. It's like, if the steering has this, how it will happen, the software bug and this and that. I'm like, most people are comfortable in electric cars. It has the fire ability that if it catches on fire and if you do not get out instantaneously, yeah, there won't be a dead body to find. You will be poofed out of existence. So that's the whole point. There is a very loud minority, but those are not the real people. So what about the most people? Well, most people just want a vehicle to go from A to B. And in Indians, we already saw this happening right in front of our eye, how India switched from a bike only to scooty. Now, here's in early days, I'm old enough to remember this. Early days, people were like, scooty is for girls, or like, scooty is a toy. And now even older people was like, yeah, I'm just driving a scooty. Now, why? How the heck that happened? Somebody who was designing scooty had the wisdom to, it's like, hey, let's push CVT into this, basically constantly variable transmission. Benefit of that, there is no good. There's nothing like that. It's just nothing more than that. It just flew out of the lots, brick by brick, day by day. And 2024 could be the year where this overtakes bikes in new sales. So how the heck that happened? Again, this is far more convenient from A to B. I'm just waiting for either this company to realize they can build a bike with CVT, or a motorbike company to realize the reason why their sales are down is because they do not have CVT. Let's see who cracks first. So if drive-by-wire systems make your life easier, people will pay for it. Nobody wants to like Fast and Furious doing it. Looks cool, but it's not fun. It's not fun. So it's one of the, and be mindful, we are going to self-driving system. Having a drive-by-wire hardware only makes that job easier. So it's one of those things. And if you're like, what if this happens, what if that happens, what if EMP boom happens, what if this happens, it's like there is no answer to that. Yes, we have drive-by-wire aircrafts, and yes, it has caused accident. But then what? Would you undo all the aircraft? Hell, no aircraft manufacturer will allow you to do that. No FAA agency will allow you to do that. Nobody wants to do that. It's like, yeah, there was a software glitch that should not have been there, but they patch it, they fix it. That's how it works. So it's one of those. And be mindful. If you ever looked at four-steering car, like basically all four wheels are steerable, it always had computer. Because in the rear wheel system it has to counter rotate, meaning when you are turning from a slow radius, it has to counteract your steering. Basically it has to go opposite. The two wheels has to go, if your two wheels are like this, it has to go like this to turn. At high speed, if it does like that, yeah, you're gonna crash. So at high speed it has to do parallel. It's very hard to do. So at 2 it parallels it, grabs it. We already had it, nobody even complained about it. So it's one of those things that if this then that has no answer. You have to genuinely understand. And if you are that kind of individual, why are you getting in car? Car is the most likely chance of going poof. Like, you are more likely to survive an aircraft than you are likely to survive a car, factually speaking. So I do see drive-by-wire becoming an absolute thing in future, and I do want that 48-volt system in most systems. I genuinely do not like the 12-volt system right now. So this was my presentation on drive-by-wire car system. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.